Section 7.4, percent increase or decrease. In this video, we will investigate some practical applications involving percent increase of a salesperson's salary, percent decrease of populations in Silvertown and Millertown, and the discount of a pair of ski boots. Increase. A person's salary can increase by a percentage. A town's population can decrease by a percentage. A clothing firm can discount its apparel. These are the types of applications we will investigate in this section. Percent increase. A salesperson is granted a 5% salary increase. If the salesperson's current salary is $4,000 per month, what will be his new salary? Solution. Let X represent the salesperson's salary increase. Then we can translate the problem into words and symbols. The salary increase, which is X, is equal to 5% of or times the original salary of $4,000. Solve for X. X equals 0.05 times 4,000, since 5% equals 0.05. So 0.05 times 4,000 is 200, hence X equals 200. Therefore, the salary increase is $200. To compute the new salary N, we must add this increase to the original salary. So the new salary N is equal to the original salary of 4,000 plus the increase of 200. Thus, the new salary N is 4,200 per month. Alternate solution. If the salesperson is to receive a 5% increase in his salary, then his new salary will be 105% of his original salary. Let N represent his new monthly salary, then the new salary N is equal to 105% of or times the original salary of 4,000. Solve for N. N equals 1.05 times 4,000, since 105% equals 1.05 as a decimal, and 1.05 times 4,000 equals 4,200, which is the same answer. Example 2. A salesperson making a salary of $4,500 per month has a salary increase to $5,000 per month. What is the percent increase? Solution. To find the increase in salary, first subtract the original salary from the new salary. So the salary increase equals the new salary minus the original salary, which is 5,000 minus 4,500, which equals 500. Hence, the salesperson sees an increase in salary of $500. Next, let P represent the salesperson's percent salary increase. Then we can translate the problem into words and symbols. The salary increase of 500 is equal to what percent P of or times the original salary of 4,500. The computed property of multiplication allows us to change the order of multiplication on the right-hand side of this last equation. So we get 500 equals 4,500 P. Solve for P. To solve for P, divide both sides by 4,500. On the right, 4,500 times P divided by 4,500 is P, and on the left, 500 over 4,500 reduces to 1 over 9 if we divide both numerator and denominator by 500. We need to change P equals 1 over 9 to a percent. We can find an exact answer by creating an equivalent fraction with a denominator of 100. So 1 over 9 equals equivalent fraction n over 100. We'll cross multiply to get the product of 9 and n equal to the product of 100 and 1, which is 100. We'll divide both sides by 9 to get n by itself. On the left, 9 times n divided by 9 is n, and on the right, 100 over 9 is equivalent to the mixed fraction 11 and 1/9. Hence, the percent increase is P equals 1 over 9 equals 11 and 1 over 9 over 100, since n is 11 and 1 over 9, which is equivalent to 11 and 1/9%. Alternative solution. An alternative approach is to ask what percent of the original salary equals the new salary. In this approach, let P represent the percent of the original salary that equals the new salary. The new salary, 5,000, is equal to what percent P of or times the original salary of 4,500. Solve for P. 5,000 equals 4,500 times P, since we can change the order of multiplication on the right. Then we'll divide both sides by 4,500 to get P by itself. On the right, 4,500 times P divided by 4,500 is P, and on the left, 5,000 over 4,500 reduces to 10 over 9 if we divide both numerator and denominator by 500. We need to change 10 over 9 to a percent. Again, create an equivalent fraction with a denominator of 100. 10 over 9 equals n over 100. Cross multiply to get 9n equals 1,000. Then divide both sides by 9 to get n equals 111 and 1/9. Thus, P equals 10 over 9 equals 111 and 1/9 over 100, since n equals 111 and 1/9, which equals 111 and 1/9%. Hence, the new salary is 111 and 1/9% of the original salary. To find the percent increase, subtract 100% from 111 and 1/9% to get 11 and 1/9%. This represents an 11 and 1/9% increase in salary, which is the same answer garnered by the first solution technique. Percent decrease. Example 3. Due to a mill closure, the population of Silvertown decreases by 8.5%. If the original population was 10,200 hardy souls, what is the new population? Solution. Let X represent the population decrease. Then we can translate the problem into words and symbols. The population decrease of x is equal to 8.5% of or times the original population of 10,200. Solve for x. In the equation, x equals 0.085 times 10,200. 8.5% converts to decimal 0.085. And 0.085 times 10,200 is 867. Therefore, the population decrease is 867. To compute the new population P, we must subtract this decrease from the original population. The new population P is equal to the original population 10,200 minus the population decrease of 867. Thus, the new population is P equals 9,333 hearty souls. Alternative solution. Subtract 8.5% from 100% to obtain 91.5%. Thus, if 8.5% of the population leaves town, then 91.5% of the population stays. Thus, the new population P is calculated from the original as follows. New population P is equal to 91.5% of the original population, 10,200. Solve for P. P equals 91.5% times 10,200. 91.5% converts to the decimal 0.915. And 0.915 times 10,200 is 9,333, the same answer. Example 4. Millertown falls on hard times and its population decreases from 11,256 to 10,923. In the space of 1 year, what is the percent decrease rounded to the nearest hundredth of a percent? Solution. To find the decrease in population, first subtract the current population from the original population. Population decrease equals original population minus current population, which is 11,256 minus 10,923, which equals 333. Hence, the population has decreased by 333 people. Next, let P represent the percent population decrease. Then we can translate the problem into words and symbols. The population decrease of 333 is equal to what percent P of or times the original population of 11,256. Solve for P. Divide both sides by 11,256 to solve for P. On the right, 11,256 times P divided by 11,256 is P, and 333 divided by 11,256 approximately equals 0.02958. To change P to a percent, move the decimal point 2 places to the right and append a percent symbol. P approximately equals 2.958%. We are asked to round to the nearest hundredth of a percent. The rounding digit is 5, the test digit is 8. Because the test digit is greater than or equal to 5, add 1 to the rounding digit and truncate, that is, P approximately equals 2.96%. Thus, the population of Millertown decreases approximately 2.96%. Alternative solution. An alternative approach is to ask what percent of the original population equals the new population. The new population is 10,923 is equal to what percent P of or times the original population of 11,256. Solve for P by dividing both sides by 11,256. On the right, 11,256 times P divided by 11,256 is P, and on the left, 10,923 divided by 11,256 equals 0.97041, approximately. To change P to a percent, move the decimal 2 places to the right and append a percent symbol to get 97.041%. We are asked to round to the nearest hundredth of a percent. The rounding digit is 4, the test digit is 1. Because the test digit is less than 5, leave the rounding digit alone and truncate, that is, P approximately equals 97.04%. Thus, 97.04% of the Millertown population remains. To find the percent decrease, the percent that is left, subtract 97.04% from 100% to get 2.96%. Hence, the population of Millertown decreases by 2.96%. The same answer. Discount. Another important application of percent is the discounting of goods. Example 5. A pair of skis is marked at $310. However, a sign in the shop indicates the skis are being discounted at 15%. What will be the new selling price of the skis? Solution. Let D represent the discount in dollars given for our pair of skis. Then in words and symbols, discount D is equal to 15% of or times the original marked price of $310. Solve for D. D equals 15% times 310, and 15% converts to decimal 0.15, hence D equals 0.15 times 310. And 0.15 times 310 equals 46.50, hence the discount is $46.50. To find the new selling price, subtract this discount from the original selling price to get 310 minus 46.50, which is $263.50. Hence the new selling price is $263.50. Alternate solution. Subtract 15% from 100% to obtain 85%. That is, if an item is discounted 15%, then its new selling price, S, is 85% of its original marked price. So the new selling price, S, is equal to 85% of or times the original marked price of $310. Solve for S. S equals 85% times 310, and 85% converts to 0.85 as a decimal. So S equals 0.85 times 310, and 0.85 times 310 is 263.50. Thus the new selling price is $263.50. The same answer. Example 6. A pair of ski boots marked at $210 is sold for $180. Find the percent discount correct to the nearest tenth of a percent. Solution. We can find the discount in dollars by subtracting the sale price from the original mark price. Discount equals original mark price minus the sale price, hence $210 minus 180, which is 30. Hence, the boots are discounted at $30. Let P represent the percent discount. Then in words and symbols, discount of 30 is equal to the percent discount P over times the original mark price of $210. Solve for P. Change the order of multiplication to get 30 equals 210 times P. Then divide both sides by 210 to get P by itself. On the right, 210 times P divided by 210 is P. And on the left, 30 over 210 reduces to 1 over 7 if we divide numerator and denominator by 30. Hence, P approximately equals 0.1428. To change P to a percent, move the decimal point 2 places to the right and append a percent symbol to get 14.28%. Round to the nearest tenth of a percent. The test digit is 8 and the rounding digit is 2. Because the test digit is greater than or equal to 5, add 1 to the rounding digit and truncate. Thus, correct to the nearest tenth of a percent, the percent discount is approximately 14.3%. Alternate solution. An alternative approach is to ask what percent P of the original mark price equals the selling price. The new selling price of 180 is equal to what percent P over times the original mark price of 210. Solve for P. We have 180 equals 210 times P since we can change the order of multiplication. We'll divide both sides by 210 to get P by itself. On the right, 210 times P divided by 210 is P. And on the left, 180 divided by 210 is 180 over 210, which reduces to 6 over 7 if we divide numerator and denominator by 30. Then 6 over 7, or 6 divided by 7, approximately equals 0.8571. To change P to a percent, move the decimal point 2 places to the right and append a percent symbol to get 85.71%. Round to the nearest tenth of a percent. The rounding digit is 7. The test digit is 1. Because the test digit is less than 5, do nothing to the rounding digit and truncate. Thus, correct to the nearest tenth of a percent, P approximately equals 85.7%. Thus, the new selling price is 85.7% of the original mark price. Subtract 85.7% from 100% to get 14.3%. That is, if the new selling price is 85.7% of the original price, then the percent discount is 14.3%. This is the same answer found with the first method.